All right, so we're moving on to Gay-Lussac's law. And Gay-Lussac, his law dealt with, as I mentioned in the previous videos, pressure and temperature. And whereas pressure was in atmospheres, I'm trying to slide on and see if that helps any. Like this is hard to see, but I feel like that makes it worse. I don't know which one's worse. I'm tearing things up, I think. All right. I think it's better with the light. I'm going to go with the light. All right, so P is pressure, that's in atmospheres. T is temperature, which is in Kelvin. So if it's not in Kelvin already, you're going to have to convert it. If it's not in atmospheres already, you're going to have to convert it. The very first step is you're going to cross multiply just like you did with Charles' law and now Avogadro's law. And it's P1 times T2 equals P2 times T1. I'm just going to circle what you're looking for and move on from there. At this point, if you know what you're doing, you can go ahead and stop the video, but I'm just going to keep the video going with examples for those that need the example. All right, so we have a problem here, and it says a gas cylinder container has a pressure. So this is a pressure, this is our P1, and a temperature at 30 degrees, this is our T1. If the pressure in the container is increased to 201 kPa, so that's our P2, what is the new temperature? We're looking for T2. Okay, so I have some converting to do because my pressure needs to be in atmospheres and my temperature needs to be in Kelvin. So when I start converting, I've got 125 kPa, and I need to go from kPa to, here's the 101.3. You guys don't hang me if I'm wrong on that. Go into atmospheres. And every 1 atmosphere is 101.3 kPas. And then I'm going to get that in atmospheres. And then I have 201 kPa. And I'm going to go 101.3 kPa equals 1 atmosphere. Once again, don't shoot me if that's not the right kPa. I'm pretty sure it's correct, but it's been a long couple of weeks. All right, so this one's going to give me 1.23 atmospheres, and this one is going to give me 1.98 atmospheres. Okay, and then we've got 30 degrees Celsius. I also cannot leave that alone. I have to put it in Kelvin, so I'm going to add 273. Which is going to give me 303 Kelvin. Okay, from here, I just need to look at my formula. I cross multiplied. I got P1 times T2, P2 times T1. Remember, those can be swapped around. And I'm looking for T2. So I'm going to circle what I'm looking for, divide by everything else. So divide by P1 on both sides. And that is going to cancel out P1. So T2 equals P2 times T1 over P1. P2 in this situation, sorry, this is P2, this is P1, and this is T1. P2 is 1.98 atmospheres. T1 is 303 K. And P1 is 1.23 atmospheres. Notice that your atmospheres are canceling. So you've got 1.98 times 303 divided by 1.23, and it should give you 487.76, and that is Kelvin. And so looking at the reasonableness in this, we talked about before that these are directly proportional. And if we look at our two pressures, this pressure went up So we would expect our temperature to also go up. So that is a reasonable answer. And this is what your T2 is. If you guys need any more videos, just send me messages. Let me know. I don't mind including anything that you haven't seen or working anything that you need to see worked, even if it's in part of the problems that you're expected to do.